Hello, welcome to the Water Research Foundation's webcast. Today we are going to be thinking a little bit about open source code. My name is Miriam Hacker. I'm a research manager over at the Water Research Foundation, and the focus today is doing more with less using open source code. We're going to be digging into the water reuse topic a little bit more as an example. So thanks for joining us, folks. As we go into our webcast today, if you've joined us before for other webcasts, just a little bit of housekeeping. Please feel free to submit questions anytime through our Q&A box in the screen. You should also be able to see bios of the different speakers we have today. We will have a recording available on the Water Research Foundation's website after this webcast today, and you can go ahead and download the slides right now. And there will be a link to the project page with the associated Water Research Foundation project. We'll also be sending a completion certificate after the webcast. And again, if folks have questions, I will go ahead and be monitoring those as we go through the webcast today. So thanks for joining us. We're happy to have you here. And for folks that aren't as familiar with the Water Research Foundation, our primary goal is to advance the science of water. We do that by connecting both science and practice, working with folks across the water sector. And we want to make sure that folks have the ability to answer the most pressing questions that we have in the water space today. There's a few things that happen through that process. One is generating knowledge, identifying connections between different folks in the water sector, bringing a sense of innovation to the work that we do, and then also not only developing results, but connecting them to people that have the questions. Now, for today's conversation, we're going to be taking a look at a couple different topic areas that the Water Research Foundation focuses on. What you see on your screen right now is there's 5 major themes that our research focuses on. And today we're going to be thinking about our diversifying water systems subtopic area, which is under our treatment, innovation, optimization. We're also thinking about digital transformation, which is an area that covers all of the different research themes that we talk about at the foundation itself. Now, coming into this webcast, we are here today because we had a very unique collaboration that took place over the summer. Through one of our EPA-funded projects, Unlocking the Nationwide Potential for Water Reuse, we connected with the University of Washington's eScience Institute program called Data Science for Social Good. What that is a 10-week program that brings together teams of data science fellows and folks from practice to address real-world social problems using data science. And so this EPA-funded project at the Water Research Foundation actually had a lot of data and a lot of knowledge and wanted to work with a group of data scientists to stretch how we're approaching the problem itself. And we'll learn a little bit more about it as we go. But before we go in, I just want to give a big thank you to that DSSG program over at the University of Washington. This wouldn't have been possible. The webcast wouldn't be happening without that collaboration and without people thinking creatively beyond the disciplines that we're in. So that being said, what you can expect from today's conversation is first thinking about the fact that there's a lot of folks in the utilities doing a lot of work with less resources or trying to access as many resources as possible, and thinking about one example of an open source code that's been developed as a way to do a lot with less and what it looks like in practice, specifically taking a look at its application to water reuse. We will bring in We'll bring in someone who was a senior advisor for the program. We also will be doing Q&A with this group. So again, if you have questions as we go through, I'd love to encourage you to go ahead and use that question box in your screen. Before we jump in, I also am going to ask folks in the group here if there are open source tools that you're using for your own work in the water sector. And I'm trying to think about the platform we're using right now for this webcast. But if you want to drop that in as a question, we can take a look at it. And maybe afterwards, we can find a way to put out those results for other folks to maybe crowdsource how we're doing more with less in general. So that being said, I'm going to one of our data science fellows to talk about where we're starting with as we go into the conversation today.
Hi all, I'm Nora Provasial and I'm a graduate student studying data science at the University of California, Berkeley, and I'm excited to be here with you all today. We'll start by talking about the high-level motivation behind this webcast, which is doing more with less using open source code. So open source coding tools can expand the technical possibilities across industries, and it helps us answer questions like how can we use our already existing data and public data to generate insights for your industry? How can we do this with minimal coding knowledge? And how can we translate those results into impact? So starting with some brief definitions, software is open source when creators release it under a license granting others the right to use, change, and distribute the software freely. R is an open source programming language popular with academic researchers, which is what we ended up using for our tool. And our work builds tools for our users beyond what they get out of the box for prepackaged types of software that's expensive. So we'll start with what our tool is called, which is GeoNdXR, and some definitions of what it is. It's a low code tool that enables our users to create custom-made dynamic websites showcasing a geographic index. It helps our index creators pre-process the data they want to include in the index, calculate it, and then map it. And it uses WebR for index recalculation and interactive mapping hosted on the user's browser, which makes sure that the longevity and affordability is preserved and the resulting dynamic website is free. So now we'll hand it off to Mbai, who will talk about the process for creating an index using our code.
Hello, I am Baisala, one of the data science fellows. Now let's look at the workflow of our indexing tool. To use this tool, we expect web creators to be able to gather geospatial data of their choice, whether be it water or non-water. If the collected data are in varying scales, the index creators can use our crosswalk functions to transform their variables to their target scales. For example, from state to county level, county to census tract to water service area, and so on. We also allow point data, that's longitudes and latitudes, polygons, rasters, and tabular data with ID columns to be used in our crosswalk functions. The index creators can group different variables or indicators into categories or drivers. We map each driver to a list of indicators to ensure this functionality. This affects how the index is calculated and menu items displayed on the final website. After pre-processing and bringing all the data to the same geographic scale, we transform the non-percentile variables into percentiles. This ensures that the data is comparable across different metrics and categories, regardless of their original units or scales. A final step before doing the dimensionality reduction is the assignment of weights to drivers. The web creators have the flexibility to select the weight of each driver based on their perceived importance of the driver in the context of the overall index. The ability to assign weights gives the web creator flexibility in tailoring the index to specific objectives. By adjusting the weights, the creator can emphasize certain aspects of the data that are more relevant to the goals of the analysis. Finally, we conduct a dimensionality reduction using principal component analysis, that is PCA. PCA is a technique that reduces the dimensionality of a data while preserving as much of the variance as possible. It identifies the key components in the data that capture the largest amount of variability. Once the principal component of each driver is obtained, we take the weights provided by the index creators, multiply them with their corresponding principal component, and sum them up to get the weighted average. The resulting index is a powerful tool for the comparison and ranking of geographic regions or aggregated data. We use WebR, a WebAssembly framework for R, to build the website that hosts the map. WebAssembly allows us to run R code directly in the browser, which eliminates the need for a server to host the map. This setup is particularly efficient because it enables the map to be displayed and interacted with entirely on the client side. This is achieved by compiling the R code into WebAssembly, allowing the map and its functionalities to run smoothly in the user's browser. As a result, users can interact with the map instantly without the complexity of server-side processing. Now let's look at the ethical considerations. With our tool, anyone with at least some experience working with data and R can create a website based on their interests. The fact that we are making index creations more accessible for index creators by making the index creations and mapping process easier allows the index creators and explorers with limited resources to make data-driven decisions. On the other side, our tool might be used for manipulation by providing it with biased data or helping people cherry-pick data to support a narrative. We thought hard about this as a team and agreed that we couldn't prevent the abuse of an analytical tool without eliminating the flexibility that stakeholders value. The only real solution is maximum transparency. To manage these ethical issues, we made a thorough process documentation of the functions we created for the index creators. We also provide a metadata information to index explorers and allow them to download the data used in the index calculation for more transparency too. So now I will hand it back to Nora to explain how we approach the problem during the summer.
Exactly. So now we're going to give you a little bit of backstory as to how GeoNdXR came about over the past summer, working as data science for social good fellows at the University of Washington. And we'll look at how we developed this tool in the context of our original project, which was about water reuse. And so we can treat the water reuse application of GeoNdXR as a case study for how it works in practice. And our original research question we were seeking to answer before we came up with this tool was, how does the potential benefit from adopting water reuse systems vary across the United States based on local water stressors and needs? So now we will start by giving some background context about the motivation of the project. As many of you are probably aware, the conversation around water reuse infrastructure adoption is gaining traction across the United States. For those of you who are a bit unfamiliar, I'll start with some context about water reuse and then dig into how our project relates to it. So we'll begin with how urban water systems in the US work, starting at the top of this diagram on the right and moving clockwise. Drinking water treatment plants take water from the natural environment, clean it, and pump it to your tap. Once the water has been used, for example, flush down the toilet, it becomes wastewater, also called sewage. This gets combined with other industrial and agricultural water, as well as rainwater and runoff from streets. That wastewater then goes to wastewater treatment plants, where it's treated to an acceptable level determined by place-specific regulations and sent back into the environment. So where does water reuse come into this story? It's a way of moving away from a one and done approach to water towards a more circular and sustainable one. And wastewater and stormwater can be treated up to acceptable water quality levels to be repurposed for agriculture, toilet flushing, and sometimes even for drinking. So it's a way of increasing water sustainability in our world. That's where more water challenges are becoming frequent. So, what drives a community to explore water reuse? Communities are motivated to adopt water reuse in different ways and to varying degrees. On a high level, there are many environmental and economic benefits of water reuse at both utility and household levels. Our project leads, who are water reuse subject matter experts, created a comprehensive set of drivers, 4 of which are shown on the left. The drivers at the top row of boxes include effluent disposal limitations, extreme weather events, community health resilience, and runoff management, and more. And the white boxes below them represent measurable indicators to determine the severity of the above drivers. The point here is that it's actually very complicated to determine the comprehensive picture of local water needs and conditions, as well as the net benefit that adopting water reuse could provide to communities. However, there is a lot of publicly available data to start to piece the puzzle together of all these different drivers. And most of it is available through sources like the US Census Bureau and the Environmental Protection Agency and some other open source platforms. So our original approach to tackle this problem was to create and map an index that could quantify the overall potential benefit of water reuse based on the severity of these many different drivers all pulled together. And there are some examples here on the left of other types of indices that we're talking about. So across disciplines, indices are used to collapse multivariate complex phenomena into a single metric that can be easily compared across geographic scales. And some of you might be asking, why is an index the best way of delivering this information? And in the initial phase of working on this project, we were looking at the index creation process through a bird's eye view to come up with an answer to that question. So after conversations with researchers in the water sector, as well as at the UW Science Institute, we found that researchers tend to have this love-hate relationship with indices because they are inherently reductive. They also mean something only if the index creator is very transparent and trustworthy about their process of creating it and can select appropriate data and make fair calculations to really represent what's going on. But at the end of the day, indices are incredibly useful and important tools to inform policy and convey complex information to a general audience. And they're particularly powerful because people are really used to seeing them. So this got us thinking, if everyone is making indices, there has to be some kind of general process that index creators take to make them. But we didn't find any such generalized process or tool for end-to-end index development out there. So that's kind of where we decided to make our solution very generalizable and reproducible. We also started thinking about people who use indices, index explorers, and what they want from an index. So we wanted to provide them with the most transparent and empowering index possible. And we incorporated these ideas into our project and leveraged frequent stakeholder input through the project to guide our design as we developed GeoNdXR. And as we kept developing, we realized that key things we needed to prioritize were flexibility, transparency, and ease of use. And so now I'll hand it off to Ji-hyun, who will explain that further.
Yeah, thanks, Nora. I'm Ji-hyun. I'm going to walk you through how our tool is different from existing approach and how we can contribute to the more transparent research pipeline. So although delivering an index itself was a viable solution, we wanted to address a wider range of concerns that have been easily identified but have been overlooked by existing framework and a lot of indices that exist out there. So there were several problems that quickly caught our attention in the original approach. First of all, having a single index could not adequately reflect region-specific problems. For example, shoreline counties cared more about saltwater intrusion than landlocked states. Plus, different index users, index explorers, had varying goals and use cases simply by interpreting a single index. For example, we had a chance to conduct interviews with stakeholders, potential users who are affiliated with professional water research associations. And we realized that policymakers and researchers had slightly different ideas on what should be included in the index and how we should organize different drivers or stressors of water reuse potential. Some people wanted to put greater emphasis on water treatment facilities, while others wanted to put more emphasis on environmental impacts. Now, generating a one-size-fits-all index had some limitations in many respects, including these two problems that I just highlighted. Now, there were also procedural challenges from creating a single index. Our main stakeholders, who are very proficient in R coding skills, anticipated a long-term difficulty in terms of maintaining water reuse index, since you had to recreate the whole process and update the index whenever new data sets become available every single year. We wanted to reduce that type of redundancy by streamlining the index creation process and offering a useful toolkits that can benefit most of the index creators that across different domains. Now, if we consider this background and moving on to the next slide, we came up with a general solution to this problem. Instead of creating a specific index for water reuse potential across the US, we aimed at creating a flexible and open source indexing tool that supports geospatial data across domains. The key really was customization and flexibility. So customization happened on two levels. From the index creator's perspectives, they could easily change the organization of different variables and relabel them accordingly, whether it be water reuse driver, or any sort of subject that they're interested in. from the index explorer's perspective, they would face a web page that's interactive. This means that if there is certain variable that they wanted to take out from the index construction, now end users, index explorers, without having to rerun the entire code, could easily unselect variable and generate their own index. And decision to make our program open source meant our commitment to full transparency as well. This also meant multiple things. First, every single element that we used to construct this GeoNdXR is publicly available. And anyone can use the tool cost-free. We had to leverage state-of-the-art WebAssembly to execute this transparency, and WebAssembly allowed us to execute our code without any designated server. Now, index explorers can interact with our functions that we created without even having to install R on their own laptops. It also meant that any R users could recommend modifications to our current version, being completely open source. Our general solution also meant greater applicability across different domains. As Mbaya's introduced crosswalks earlier on the slide, we have written codes that translates a geospatial data set on one scale to another, for example, census tract to county and vice versa, and instead of directly merging data sets at hand. And these crosswalk functions could be possible not just water-related map, but any maps that go beyond the water sector. So after building a general tool for index creation, we used our very own tool to create the water reuse potential index. In sum, we switched from specific index to a general solution that benefits a research community that goes beyond water use sector, and we envisioned not just a single index, but an indexing tool. Now I'm gonna hand it off to Daniel, and he's gonna walk us through more specifics of the GeoNdXR.
Thanks, Jihyun. Hi, everyone. I'm Daniel, a master's student in data science at the University of Washington and one of the student fellows on the project. We took those requirements that Jihyun just talked about, an indexing tool that's open source, flexible, and customizable to the many different needs that we heard about in our stakeholder interviews over the summer, and we made a tool called GeoNdXR. GeoNdXR is, our goal with this tool is to make indices more accessible, helping index creators who are comfortable working in R calculate an index from the data they're interested in, create a dedicated web page for it, and share that index with explorers on the internet. Now, how did we make this work concretely? Well, we've started to make a series of tools and tutorials available via GitHub, which is a code sharing and review service some of you might be familiar with, to index creators. These resources walk them through using R functions to get their data ready, calculate their index, put it on an interactive map like the one you see on the slide, and make the map available to index explorers. Now, by default, the map is going to showcase an index calculated from variables and weights selected by the original index creator. From there, explorers can select a subset of these variables to recalculate the index. The way we do this is what sets GeoNdXR apart from a technical perspective. It allows creators to publish indices for explorers to view in ways that are free and don't have a finite lifespan. Normally, when you visit an interactive website, like, for example, think of your bank, and you enter some user input and you expect a response, all of the computation that's producing that response and processing the data you've entered happens on computers paid for and maintained by whoever's hosting the application. This is how pretty much all traditional data science dashboards work. But if index creators depend on servers like most web applications do, the shelf life of the index is only as long as that index creator is willing to pay for and maintain it. GeoNdXR helps us get around this. It uses a technology called R in WebAssembly to harness the index explorer's computational resources. That means all the computations that you see on the slide to produce this map happen in the end viewer's browser. This in turn means that they aren't reliant on the index creator paying for things like hosting costs to maintain that access into the future. Once we had built GeoNdXR, we used it to deliver the water reuse potential index. This provided an answer to our research question, and it addressed our direct stakeholders' needs. But it's also very flexible. On the next slide, I'm going to show you how a provisional version of that index using data we had in the summer. But the key thing to understand here is that because we delivered this using GeoNdXR, it was really easy for our main stakeholder to update this over time as new data came in and as the index evolved. This would have been much more challenging before GeoNdXR. Next, I want to walk through how a water reuse index explorer might interact with the output from GeoNdXR. Before I move on to that, I want to make a quick note that the slides that we're making available are going to contain a link to a live demo that you can click through yourselves to explore a little bit how an end explorer might see the water reuse index. But for now, I'm going to step through slides showing some of the key features. So a map created by GeoNdXR is going to open like any ordinary website in your browser. It's going to have a key, and that key is going to explain, in this case, how water reuse potential breaks down across the US. And the creator can customize the grades that you see here, the shading from light blue to dark blue. The left-hand toolbar, which is on the left-hand side here and grayed out, is going to show the explorer the drivers that sit behind the index that they're looking at. Now, if explorers want to zoom in on certain sections of the map and look at more detail, they can zoom in on particular regions, and the index value is highlighted for them. They can easily revert to the original view by just clicking on a button at the top left. And index explorers can also recalculate the index by selecting the variables, choosing them from the drop-down list on that left-hand side, and they'll see within their browser an update to the index value in the region of interest. So if a water reuse index water stakeholder says, actually, I'm curious to understand what would happen if we eliminated extreme weather events in the calculation of this index, they could uncheck those indicators here, as you can see on the slide, and visualize what the index would look like without accounting for those variables. This happens, again, directly in the browser, and that's a big part of GeoNdXR's power from a technical perspective. Now that I've talked a little bit about how this works, what I'd like to do next is speak with GeoNdXR's first user. Carolyn Hayek is a water researcher at Columbia, holding a PhD in sustainable development. She was instrumental to the development of GeoNdXR through her feedback and all of her guidance to our team over the summer. And since then, she's been using GeoNdXR to develop an index of water reuse potential, very similar to the one that I just showed you. It covers water service areas throughout the US. I'd like to spend the next few minutes asking her a few questions about her experience with GeoNdXR, hopefully giving you an idea of what our users can get out of this.
Thanks for having me.
Thanks for joining us, Carolyn. Unfortunately, I don't see the questions on the slide. Okay, there we go. They're loading. So first up, Carolyn, can you give us a quick rundown of, as a baseline, how you tend to use R in your work, in your data analysis work for water research in general?
Yeah, I typically use R when I am trying to summarize data, trying to manipulate data. Like if I want to process it in a way where I can make changes to the different variables and how the units are set up and things like that. So pretty much everything in the tidyverse package, if you are familiar with R, it makes it really easy to manipulate a data frame or think of it as just a table of the data to fit what you're trying to do with it. And then you can run different types of analyses in R too. So I've done that before as well.
That makes sense. Thanks. And when you first started using GeoNdXR, can you talk to us about some of the adjustments you had to make to using this toolkit to accomplish the goal you had?
Yeah, I found it actually pretty helpful and easy to use in a lot of ways. The only adjustments that really need to be made is understanding what you would do anyway normally with a new R package. You need to understand how to put in the information so that the function can do what you want it to do. So just understanding what you need to give it, and that's typical when you're using R. The biggest work was really preparing the data. But then once it was prepared, there's a really nice sort of flow document or function that brings all of it together to create the website documents. And that was just, different than anything I've ever done before. I have never set up a website like that. So that was really amazing. It's in HTML. I don't know HTML. I have no idea how to design a website from scratch. And so it was kind of an adjustment, but it was more like a perk and a benefit.
Yeah, that makes sense. And you touched on a couple of these, but can you give us more of an idea of the specific tasks that you use GeoNdXR for in each phase of this work?
Yeah, so during the data processing, a lot of the water data or water-related data that we were using is not at a water system level. And trying to get it on the water system level can be difficult because it's not like census data where it's nested in very specific settings. You're looking at watersheds, you're looking at census data, all this stuff, and you're trying to match it to what I will refer to as a weird shapefile, right? A weird sort of shapes that are associated with the thing you're creating the index for. And so particularly when it came to aggregating information so that it would be on that level, this came in incredibly handy. And then in terms of the website setup, as I said, phenomenal.
Yeah, that's great to hear. Carolyn, you came into the project obviously with experience and expertise working in R. What would you say is the level of proficiency that someone new would need to be able to pick up this tool and make full use of it?
So I would say that at the beginning, you needed a little more proficiency while you guys were developing the tool in case you hit any snags. But the documentation has been very helpful in how to run it. And so with that new information that sort of walks you through the process, you really don't need to know a ton of R. Again, the bigger deal or reason you might want to use R, need to know R, is for getting the data ready to create the index. And if you have somebody who works with data regularly in your organization, you just let them know, you can share the guidance documents so they know what kind of format the data needs to be in, but they can use the tool to create it for you. And then you can just run it through the final wrapper. So it's one of those things where not having a ton of experience in R is not going to limit you.
Got it. And since picking up the tool, how customizable and flexible have you found it? So obviously you had quite a big role in shaping it, but since we handed it off and you've had a chance to start working independently with it, have you seen the customizability and the flexibility that we set as a goal?
Yeah, it's actually really nifty, for lack of a better, cooler word. I'm not cool. So it's, if you want to tweak the name of the website, if you want to tweak the way that the variables are set up, if you want to change entire categories or just change their names, it was very easy to do those things. So we started with, 4 drivers, and then we added information for 2 more. And that was really, putting that in was not difficult at all. And then in terms of having additional notes, there are functions for that. We chose not to use weights as we've been doing this, but the fact that you can put in weights really makes the index creation part customizable as well. So it's just, being able to map information in a helpful way. The other thing that's really cool is the whole idea of nesting information gives you more insight into what's happening with the index that you're creating. So if somebody were to go and recalculate with only a single driver, they would actually get an index for just the one driver. So in terms of being able to share the information, I don't have to create, multiple documents and multiple maps. I can just put it out there and people can make it tell them or can get it to tell them whichever piece of information they're most interested in. They can even just look at a single indicator at the water system level, which is something that we don't often have.
Yeah. Thank you. That's really insightful, Carolyn. Thank you so much for sharing a bit about your perspective. And I hope this has given folks on the webcast an idea of what GeoNdXR can do for our end users. So thanks again.
And thank you for developing it. It's been great.
It was a pleasure. So I want to close off by noting a few of our next steps in this project. Carolyn was our primary technical stakeholder over the summer, and you just heard her talk a little bit about this. She's prepared a public draft and continues to refine the water reuse index. Over time, we plan to share that index and the GeoNdXR tool with environmental nonprofit organizations like the Water Research Foundation and government agencies like the EPA that may use it to create indices to aid in informing local, state, and future federal policies on water reuse. Water utilities, we hope, could also find this tool useful to make more data-driven decisions. Finally, we envision a really broad audience and user base for this tool. We want to make it available for other potential non-water users, like educators, to provide education about environmental challenges, and even journalists and other researchers to make indices of their choice on any topic, hopefully testing GeoNdXR with a wide range of data and helping us improve it over time. I want to pass it back over to Miriam to close us out and transition us to the Q&A.
Thanks, team. What you're seeing on this webcast is a culmination of 10 weeks of fantastic effort that was put into this. And I think the team did such a great job, like succinctly explaining the process, but I need to just really emphasize to the group that they literally spoke with AWWA, with WRF folks, with state regulators, with folks from utilities, trying to understand, here's what we're thinking about doing. Does this make sense to you? And what they realized, number one, is just the extreme fragmentation in the water data that's available, but also realizing, hey, here are some tools that maybe folks on this webcast aren't particularly keen on digging into the water reuse side. I'm looking in the Q&A and I'm seeing some folks are, which is fantastic. And also, what happens if other people have this similar data? How do we get it on the same scale? Okay, well, there's a tool for that now. And what happens if you want to map it? Okay, well, now there's a tool for that as well. And I think the really cool part about this project was also thinking about the ethical considerations. What we're seeing in the water sector right now is a lot of conversation about the digital transformation, thinking about how we leverage tools to improve and optimize the way that folks operate. And what are the considerations that need to be taken into account when we're thinking through those steps? And I think that was a really intentional conversation that happened amongst this group of fellows over the summer, and also really brought in a unique perspective. And I would say that was something for me personally from the Water Research Foundation side of things. It was really fascinating to see what we could do when we brought in folks from different backgrounds and different perspectives beyond engineering. We had folks, if you take a look at the bios, we have folks from econ, from data science, from institutional and environmental science, public health, and how do we think about what data could be used as proxies, and also what can we do to make sure that other folks that are working with large sets of data can also do something good for their target audience and stakeholder. So that being said, I do want to do a big thank you, and who isn't on this webcast today is Curtis Atkinson, who was our data scientist. He was a full-time data scientist working with our group over the course of the 10-week program period. And it was really fantastic to have insight and expertise from him. And I also want to thank the eScience Institute's staff, Sarah Stone, as well as Anissa Tanweer, program director for this project. And so big thank you to them. And now I want to move into our Q&A. And so before we jump into specific questions, Michelle, if you have a chance to drop in those links to the chat, that would be fantastic. So we're going to drop a link to the overall project website that was discussed today that can kind of give a little bit more background on the 10-week program, as well as a link to the index that Daniel and Carolyn were talking about. I'm taking a look into the Q&A right now, and I'm seeing that some folks using QGIS. I also did hear about the Tidy Water R package Brown and Caldwell has out, which is fantastic to hear about. I am really curious. There is a question coming in about, thank you, Sarah, a question about, have you considered restructuring your tool into a standalone R package? It might help with accessibility for new R users, especially people who might be unfamiliar with GitHub. I will raise my hand and say I was that person this summer. So Carolyn was the expert who knew about R and GitHub and those things, and I was the end user because that is not my particular background. And so it was very interesting to see how we communicate across disciplines. Ji-Hyun, do you mind addressing this question? And there was also something, I want to finish out the question. P.S. Use this package might give some good ideas on how you could set up. It'd be really cool to call GeoNdXR create index straight from RStudio. So Ji-Hyun, thoughts on that?
Yeah, thank you so much for such a great question and feedback. We weren't aware of use this package, and it's striking how there are packages for everything, including a package to make a package. We'll definitely take a look at that. It is our long-term goal to make it into a standalone R package. And we have been working towards that goal. And with that in mind, we wanted to keep everything very well documented and transparent. Although it's not published as standalone R CRAN package at the moment, it does include some of the package-like features. So once you git clone the entire GitHub repository, the entire folder of the codes, you will be able to search for functions. Say, for example, you would typically do a question mark and then the package name and the function, and it will show the documentation of how to use that function. Our GitHub repo at the moment does provide such features. So it would be great to have it as a GeoNdXR package, but it is still under construction. And it's open source, so we would be delighted to gather some more feedback on any users.
Thanks, Ji-Hyun. There's also another question about, Amy, thanks for asking this, about how soon do you see GeoNdXR becoming available for uses beyond water reuse data, such as mapping land use or mapping site locations within a watershed? It is available now if you have the data. So the code itself, the cool part is that the code is available. So if you have the data and it's in a place where it can be processed, you can actually go ahead and set up your own index using that data for those different applications. And that was the purpose, because we kept talking to different people in the water reuse space who all had different ways they wanted to use similar data. And then we realized, oh, what if we created something where folks could actually create something that would be useful for their specific idea in mind? Anything else from the fellows that you'd like to add to that question or that point? Maybe actually, is there, does someone want to walk through the different resources that are available for when someone accesses that code? Like
yeah, so I think,
yep.
Yeah, so I think Ji-Hyun was talking about that a little bit, where we have our GitHub repository, where if you clone that repository, you're able to actually call the functions that we created to do different crosswalking functions between geographic scales. And then also you'll be able to have the folder where an HTML file will be created once you go through the process in our documentation to set up your customized website, posting the data that you have for your specific use case, which doesn't have to be water related. And it doesn't even have to be on a national scale because our code uses OpenStreetMap, which allows you to basically interact with the map on whatever scale that you'd like.
And I think, Nora, that kind of goes to the granularity question that Daniel had about, sorry, not Daniel Vogler, Daniel audience, about the granularity. So it looks like it could be catered to a high level. So what's the smallest scale that it could go down to?
See, there's not really a particular scale, so it could be as small as you want. You just have to have a shapefile for it. So it's something that you have to be able to map. And so if you have a customized shapefile with coordinates that lay on the United States in any granularity, you'll be able to map it. So yeah.
Nice. And so let's see here. So one of the things that did come up during the presentation and during the project itself was transparency of data use, analysis, and processing. If I remember correctly, there's actually a feature where you can download the metadata so that folks understand the sourcing and how it was calculated. Is that correct? Does someone want to speak a little bit more to that?
Yeah, I can start and then someone can add detail. So the purpose of the metadata function, being able to download it, is that you can recalculate the index in whatever way you want, and then you can actually download the raw data where that index is coming from. And that allows you to either create your own visualizations to go along with the index map, so that you can have a more thorough analysis and make your own charts for a report or anything like that. And so that you have actual access to the underlying data and not just the high level visualization. So that was part of our goal of having a very transparent process, whereas a lot of indexes that you find on the internet, it's just the high level visualization and you don't really know how they're created or what goes into it. So we wanted to try to address that ethical concern of existing indices not being super transparent about the process.
Yeah. Well, and I think that also goes to Jack's question about writing detailed reports. I don't know that it necessarily can write that level of detail. There's a follow-up question that I need from Jack about the level of detail you're looking for. But in terms of what can be downloaded, I think Nora's touched on that a bit. There is a really interesting question from Daria about how was the shapefile created? Because looking at the demo index, it looks like many of the polygons may have initially overlapped. How is that dealt with? And what data did the really small polygons come from?
Maybe Carolyn can talk a little bit about water service boundaries and what goes into making them not overlap.
Sure. There are two different water system service boundaries out there that people can use. The one we chose to use was the EPA's community water system boundaries. So we didn't have, I don't believe the data set itself had any overlap. There was some artificial looking like there might be gaps and things that happens when it gets mapped in general, I think, but they didn't actually overlap in the shapefile. It's just an artifact of how Java maps things, I think. Daniel, if that was fixed, you can let me know, but I know that was a concern at one point. Yeah, so there wasn't really any overlapping. I think if you had a data set where there were overlaps, you would need to get rid of that in advance. Actually, you might not even need to, right? It would just color both and they'd overlap, right?
But yeah, maybe. But there are also ways in the pre-processing steps when you're looking at crosswalking functions and other GIS resources in R where you can validate the boundaries between shapefiles so that you can get rid of overlaps or adjust the value associated with a shapefile based on what would happen if you got rid of the overlaps so that it's still valid data for the new geographic area, if that makes sense. Yeah, so there are resources available for that.
Nice. And so going back to the granularity question, Minhazul, thank you for your question about, is the index calculation fixed at the county level? So we talked about crosswalking to different scales, but for the actual index calculation itself, are people able, I'm guessing people are able to manipulate that in the code itself, or do I have that correct?
Yeah, it's ultimately based on the destination scale that the user is interested in. Say, for example, if you want to map an index at county census tract level, which is a lot granular than the county data that we showed up as example, And we have helper functions that allow you to scale down whatever data that you have at the county level, which is high level, down to the census tract level. So those are the helper functions that are currently available. And with that, you can able to scale up or down based on whatever destination level that you intend to present to the users. And it's also available on the end user side, index explorers, to change the level of scales that they want to view the index and map it. So all that's to say is that index calculation is not fixed at the county level. It's available as long as you have the data at the specific scale, and it can go as granular as you want your index to be, as Nora has pointed out.
Great. And, so I know we're covering a lot of ground, and for some folks, this is the first time you're hearing about this tool. So just to recap, this recording will be available afterwards. There's also a link, there should be a link available for you now to go to the project website, which has detailed instructions about how to walk through it. The last couple days of this program, it was the fellows, and Carolyn was actually walking through the steps in real time and the instructions that are now available to make sure they were able to be used. And so if you have questions about that, you should be able to access it on that project website. We will also make that available with the webcast as well. But so if there's other questions, there will be resources to take a look. Let me see there, just to kind of close us out and take a look. Is the tool limited to the US? For now, yes. But hopefully there are some opportunities, and I know that we had some discussions about what this could look like in the future, and hopefully there's some code in there that can be transposed to other contexts as well, but you need a starting point. So, and that's kind of where we were for the beginning of this project. There is, let me see here, just taking another look.
Just to follow up on what Miriam has explained, yeah. So the code in and of itself is not limited to the US, but it has more to do with our crosswalk function. So when we want to scale up or down values at one scale to another, we need a population data set so that we can reweight portions of a group and we can aggregate up to another level. So since we need that kind of population information to recalculate and reassign values to a different level, we had to rely a lot on census tract data from the US Statistics Bureau. So that's where the limitation is really coming from. But as long as the users themselves have available data set on population that can function as anchor point to recalculate and reweight the population aggregation and disaggregation, you should be able to map any indices across the globe, because the OpenStreetMap itself provides a worldwide map, not just the US. And if you actually take a look at our HTML website, which I suppose is on the link, you should be able to move across different country map outside the US.
Anything else from the fellows on that point about going beyond the US? Okay. The last thing I want to bring up is maybe where this project is going. This initially started as a 10-week program, but for fellows, is there a way that folks can give feedback on the tool? What do you see happening?
Sorry, I can start. I don't know if I have feedback happening. But yes, so this is kind of an ongoing project because we weren't able to get to every single thing that we wanted to address in the very short 10-week span. But the cool thing about our project is that it's entirely open source and everybody can see exactly, every line of code that we wrote. And be able to interact with it themselves. So what we're actually hoping for is that other people can leave feedback and suggestions for us. And you're able to do that on the Issues tab of our GitHub page, if you're familiar with that model of leaving feedback. And and we'll ideally, when we all have some time, be able to actually implement the changes that people want to see, and work on this project as an open source, having an open source legacy of it beyond the 10-week program.
Fantastic. Anything else from the fellows?
Alongside the feedback, I think people also can go and contribute our project. They can just give us feedback, and also they can go ahead and improve the tool as it is open source. Someone mentioned about detailed reports. Someone can help us maybe in making that detailed report part of our project. As it is open source, anyone can contribute to it. Yeah.
Absolutely. And that's a little bit of a shift that's happening in these projects, right? When you have open source, it's crowdsourcing solutions, and giving folks tools that maybe might not have had access to before. And so it's a unique, interesting space that this team was able to go in. And so big thank you to the group, big thank you to the eScience Institute over at the University of Washington, to Carolyn as well. And I think with that, we've got 4 minutes left in this webcast, and we just appreciate everyone who was able to attend and join us for the conversation. And we will see you in the issues tab of the GitHub page. Have a great holiday season, folks.